Hello friends, welcome to all. My name is P.B. Prajapati. I am lecturer in Applied Mechanics in the Government Polytechnic, and I am teaching this subject since long. In the previous lectures, we discussed about concurrent forces, their resultant, and also methods of finding resultant force, and we discuss resolution method, and we also solve problems related to finding resultant of concurrent forces. We will take one more problem of resolution method, and then we will switch over to next method of finding resultant of two concurrent forces, that is parallelogram law. But first of all, say we are solving one problem on the concurrent forces finding resultant by resolution method. So here, suppose you are given this type of problem. So here you can see it is a concurrent force system, and here are four forces. This is 100 Newton force, 0.15 kilonewton force, 80 Newton force, and 200 Newton force are acting here on the force on this point. But here in the figure you can see this value is in Newton, this value is in Newton, this is also in Newton, but this value is in kilonewton. So first of all, what you need is to convert forces in the same unit. So here what will be convenient? To convert this kilonewton into Newton, because rest are in Newton. So writing in place of 0.15 kilonewton value as 150 Newton, because you know 1 kilonewton is equal to 1000 Newton. So 0.15 kN means 150 Newton. Then you can also see this force is not given, this is inclined force of course, but its angle of inclination with axis is not given, but it is given in terms of this vertical value and horizontal value. So we will have to find out angle of this force. So finding angle, we can say tan theta for this angle, for this triangle, tan theta is equal to 2 by 1. So inverse of that is tan inverse, will give you the value of that angle. So finding that angle, which is giving 63.43 here. So now our figure is our four forces are in the same unit, and angle of incline, this incline force is already we have written, and here actually angle of inclination of this force is by mistake not written, but it is 60 degree. So I make correction of it. So this is 60 degree. So now next step is to resolve all forces. So here considering this axis as x-axis and 100 Newton force which is acting towards left, so arrow will be towards left. Then resolved components of 150 Newton is 150 cos 60, and its vertical component will be 150 sin 60. Then resolved components of this force, which is 18 Newton. So here it is 18 Newton force, and angle is 63.43. So its cos component along x will be 80 cos 63.43, and its sin component 80 sin 63.43. And fourth force, which is already vertically upward, so it is shown full here, 200 Newton. Then sigma fx, doing summation of forces along or components of forces along x, that is sigma fx, and its sign as towards right plus. So here 100 Newton force is towards left, so its sign is minus. So minus plus 150 cos 60, because this component is towards right. Then minus 80 cos 63.43, that is this component, and calculating this value we'll have minus 60.78 Newton. Then sigma Fy, so considering vertical upward sign as plus as usual, along a y direction there are three forces, for 1 and 2, which are upward, so plus here, which is 150 sin 60 plus 80 sin 63.43, and 200 Newton force is also acting vertically upward, so it is also plus, so this will give you 401.45 Newton. Then R, which is given by a root of sigma Fx square plus sigma Fy square, and putting value of sigma Fx and Fy here, we will get R is equal to 406.02 Newton. So this is magnitude of resultant force. Then angle of resultant force alpha R is given by tan inverse sigma Fy by sigma Fx. Mind well, this will give you the value of resultant with x-axis. So here tan inverse sigma Fy, that is 401.45 divided by sigma Fx, that is minus 60.78, will give you the value minus 81.39. And if you want to locate this resultant force, then you can see sigma Fx value is minus and sigma Fy value is plus, so obviously it is falling in the second quadrant. So in the second quadrant resultant is falling, so it will make angle 81.39 with negative x-axis and in the clockwise direction. So this is how resolution method is used for finding resultant of two concurrent forces or more than two concurrent forces. I think you are now very well conversant with this method, and I think you will be confident to solve any kind of problem involving this type of situation. Now next method is law of parallelogram, and as we discuss, parallelogram law is applicable to two concurrent forces. It is not applicable to more than two concurrent forces or less than two concurrent forces. So here first of all we'll see, and this parallelogram law method is applied analytically as well as graphically. So first of all we'll see the statement of the parallelogram law, what the law is, and we'll also see the equation of the parallelogram law, and then we will derive that equation, how that equation comes. Then also we'll solve the problems using parallelogram law of forces, that is known as numerical part. So first of all, law of parallelogram, will see the statement, what this law states or suggests. So as you know, it is applicable to two concurrent forces. Say two concurrent forces are given P and Q, and angle between these two is say theta, and here is this is known as intersection point or concurrence point. So as per this law, it gives statement as, if two concurrent forces acting on a point be taken as adjacent sides of a parallelogram in magnitude and direction, then diagonal passing through its intersection gives resultant force in magnitude and direction. Actually this statement comes from graphical method. Here say force P is taken as one side like this here, and force Q is taken as other side of or adjacent side of parallelogram. So here you can then draw the complete parallelogram, which is like this, which is having characteristics that opposite sides are equal and parallel. Okay, so this is what parallelogram is. So here if we consider these two forces as the adjacent sides of a parallelogram, then drawing diagonal through the intersection point. So here this is the intersection point. If you draw diagonal passing through this, then this diagonal itself gives us the resultant force, and this is what which is stated in the statement here. So once again repeating this parallelogram law, that is, if two concurrent forces, that is this and this, acting on a point, that is on this point, can be taken as adjacent sides of a parallelogram, that is this side and this side, in magnitude and direction. In magnitude and direction means we have taken this parallel to this force, so it is in magnitude, and we are also drawing this to the scale, so it is nothing but in magnitude and parallel to this, so it is in the same direction. So it is having said magnitude and direction. Likewise Q, here we have drawn the adjacent side of parallelogram, value of which is we have taken as per scale, so magnitude, and parallel to Q, so it is in the same direction. So then by drawing this parallelogram and diagonal passing through the intersection point will give you the resultant of the two concurrent forces. So this is what the law is, and its analytical formula R is given by root of p square plus q square plus 2pq cos theta, where R is resultant of P and Q. So here P is one force, Q is other force, 2pq cos theta. Theta is nothing but angle between these two concurrent forces, and direction of resultant force is given by alpha R, which is tan inverse Q sin theta divided by P plus Q cos theta, while it was in the resolution method tan inverse sigma fy by sigma fx. Here it is tan inverse of Q sin theta and P plus Q cos theta. Here this diagram is, as I discussed earlier in the earlier lectures, this is known as space diagram, while this is known as vector diagram, because here whatever forces given are drawn to the scale and parallel to the respective forces. So whatever diagram we are getting is known as vector diagram. So here, and you can see here it is shown small p, small q, small r. Actually all these are the values of respective force in terms of scale, that is we are taking for drawing. So then finding the value of force, you will have to convert that values of scale into as per scale into newtons or kilonewtons. Now proof of this law, that is, we know R is given by a root of p square plus q square plus 2pq cos theta. So how that formula comes, now see this. Okay, so here two forces say P and Q, intersection point is O, angle between them is theta. Then first of all what we'll do, we'll draw the parallelogram. So here parallelogram, that is O A C B is the parallelogram drawn as per the forces given and to the scale, right? So here actually OA gives you force P, and OB line gives you force Q, because it is drawn for force Q, and here in diagonal passing through intersection point gives you resultant. So R is nothing but resultant of P and Q. If you draw projections from this point C, then it will be here this line and this line, as I mentioned earlier, as per the characteristics of parallelogram, is equal. So it is Q, and its direction is also same. So whatever this angle theta here is again same here, theta. So projecting this from C here, we will get this vertical component. It is nothing but a component of q, so it is given as q sin theta, and this component actually it is horizontal component of q, and we know that component is given by q cos theta. So actually this force q is resolved into two components, q cos theta here and q sin theta, that you are well aware of this resolution. Okay, so here now in the triangle ODC here, this angle, this triangle O, D and C. So in this bigger triangle you can see, as per Pythagoras law, OC square, that is this is hypotenuse, so OC square of that square of that is equal to square of this plus square of this, that is OC square is OD square plus CD square. So OC square again is given by OA, OD is nothing but OA plus AD, right? So OD can be written as OA plus AD, so square of that plus CD square. Then we can expand this term OA plus AD square as OA square plus AD square plus 2OA into AD. This is what you have learnt in mathematics. So expand, it is nothing but the expansion of OA plus AD square, CD square as it is. Okay, then R square, OC is nothing but OC suggesting what? R, right? So it is R, so R square is equal to OA is nothing but P, so P square here plus AD square, that is square of Q cos theta, so Q cos theta square plus 2PQ cos theta, so here plus 2 OA means P, and AD is nothing but Q cos theta plus CD square, that is Q sin theta square. So putting all these values here and simplifying, we will get P square plus Q square. This will give you Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. So on simplifying, we will get P square plus Q square. Here Q square cos square theta plus Q square sin square theta is common. Q square is common here, so Q square into bracket cos square theta plus sin square theta, and this term plus 2PQ cos theta. So, and here cos square theta plus sin square theta is equal to 1. That is also you have learned in the mathematics. So here R square is given now as P square plus Q square plus 2PQ cos theta. And if you want to find out R, then R is equal to given as root of all these terms. Okay, so this is how formula of R comes. Now you see, so R is written in the terms of root of P square plus Q square plus 2PQ cos theta, and this will give you the magnitude of resultant. But as I said earlier, magnitude only is not sufficient for knowing resultant force. It requires its direction also. So for finding the direction of resultant force, say with we want to find out direction of resultant force with respect to force P, then that is said as angle or direction of resultant force is given as alpha, and that is of resultant, that is alpha R, and say with respect to P, then we can say it is alpha RP. So to find equation of direction of resultant, see we in the previous figure, as you see, this type of triangle we considered, that is bigger triangle ODC. So from the geometry of this triangle, we can write tan alpha is equal to CD, that is this opposite side divided by adjacent side, that is CD by OD, and CD is nothing but what? Q sine theta, right? So Q sine theta, and OD, so OD is nothing but P plus Q cos theta. So it is written here. So alpha can be given as tan alpha is equal to this value, so alpha is equal to tan inverse of this value. So it is given as tan inverse Q sine theta divided by P plus Q cos theta. So this is what equation of direction of resultant force with P. So I already discussed about statement of parallelogram law and its proof. Now we'll solve problems using parallelogram law, and that is also known as numerical part of this law. So here, say we are taking one problem. Here data is given as two concurrent forces. As you know, this parallelogram law method is applicable to two concurrent forces only. So here say two concurrent forces of 100 Newton and 80 Newton act on a point having an angle 135 degree between them. Find resultant force by parallelogram law analytically and graphically. So here two concurrent forces like P 100 Newton and Q 80 Newton are given, and angle between them is 135 degree. So this is what space diagram is, and you want to find out say resultant force graphically, then what you have to do, you will have to prepare a parallelogram. So for graphical method we of course need scale. So first of all you will have to draw space diagram considering one line as line of P, and then Q line or direction of P you will have to draw with the help of protractor. That is, you will have to measure with the help of protractor 135 degree with P, and in that direction you will have to mention as Q. So this is how space diagram is done. Then using this space diagram we will draw parallelogram. So here then for drawing this parallelogram we are taking this scale. Suppose here scale is taken 20 Newton is equal to 1 centimeter. We can take scale as per our requirement, but you will have to keep in mind that you choose a scale such that figure is not becoming too small or too large. So we'll consider or we'll select a scale accordingly. So here say I have, for my convenience or to draw a figure of sizable amount, I have taken this scale as 20 Newton is equal to 1 centimeter. So here first of all what I will do, I will draw line parallel to force P, and as per scale here it is P 100 Newton, so I will take or I will draw this line parallel to force, this force P, and length of which will be equal to 5 centimeter, because 1 centimeter is equal to 1 centimeter showing 20 Newton force. So here 100 Newton force means this line we are drawing 5 centimeter long. Then through this point we will draw a line parallel to force Q, but again with scale. So that force is given 80 Newton, so we will draw a line as per our scale 4 centimeter long. So from this point we will draw 4 centimeter long line parallel to Q, and then you complete the parallelogram. Okay, then what we are doing, how we are getting resultant, drawing diagonal through the intersection point of the forces. So you draw diagonal then through the intersection point. So this diagonal is nothing but the resultant force. So it gives you the value of, by measuring this length of diagonal in centimeter, we will have then resultant force in Newton. So by measuring this length, we will have resultant force from scale in our required unit. Then measuring angle of this resultant force, or say diagonal here, with respect to this line, that is with P, by means of protractor, we can directly measure the angle by means of protractor here. So that angle is the angle of resultant force, which is alpha r, and that on measuring gives the value 53 degree. While here resultant force in magnitude, say that length is 3.55 centimeter we are getting, and converting from scale, that is 1 centimeter is equal to 20 Newton, we are getting resultant force 71 Newton. So here by graphical method we are getting values of magnitude and direction of resultant force, and say then we want to compare the results with analytical method, then we can use numerical part, or say equation or formula. So R is equal to, as per parallelogram law, R is given by root of p square plus q square plus 2pq cos theta. So putting values of p, q and their angle in between them, theta, and theta here is 135 degree, p is 100 Newton and q is 80 Newton. So putting all these values in the equation, root of 100 square plus 80 square plus 2 into 100 into 80 into cos theta, that is 135 degree. Simplifying this or calculating, it will give value of resultant force 71.32 Newton. So this is the magnitude of resultant force, and angle or direction of resultant force alpha r is given by tan inverse of q sin theta divided by p plus q cos theta. So putting all values of q and p and q and theta in this equation, we will get alpha r, and that is coming 52.48. and mind well, this is of course with respect to p. Suppose you want to find out angle of resultant force with respect to q instead of p, then what will be the change in the formula of direction? Alpha r, tan inverse, instead of q sin theta, that value will be p sin theta, divided by, instead of p here, q, and instead of q here, p. So this formula becomes tan inverse p sin theta divided by q plus p cos theta, and this will you give the angle of resultant force with q. But normally what we are doing, we are keeping one formula in mind, and we are finding the angle with p usually. So you will have to remember formula alpha r is equal to tan inverse q sin theta divided by p plus q cos theta. So this is what angle of resultant is. So now we can compare the results because we already calculate the value of resultant graphically and analytically. So here graphically that value coming 71 Newton, while here it is coming 71.32. So there is slight difference between these two values, but in graphical method, as you know, it is not a accurate method. It will give values near to the numerical value or even mathematical value. So but it is easy and convenient method, that is why we adopt graphically methods sometimes. So here, but you can comparing you see these two methods actually gives you the almost same values. Comparing angle alpha r, here it is we are getting 53 degree, while here it is coming 52.48. So actually these values are very much near. So this is how the problem related to finding resultant force by parallelogram can be solved by graphically and analytically. Then one more problem on parallelogram law. Suppose you are given two concurrent forces, one is P, which is 10 kN, and other force is Q, and it is 15 kN, and angle between these two is say 60 degree. Then straightway even this problem can also be solved by resolution method and by parallelogram law. So here I have tried to give glimpse of all means two methods altogether. So solving this problem by resolution and parallelogram, and you will see values coming will be exactly equal. So by resolution, P remains as it is, Q is inclined, so its a component along X and Y are written here. So 15 kN force, angle 60, so 15 cos 60 along X, and along Y 15 sin 60. Then sigma of X 10 plus 15 cos 60, sigma of Y it is 15 sin 60 will give you sigma of X 17.15 and sigma of Y as 12.99 kN. Then R is given by root of sigma of X square plus sigma of Y square. Finally we will get value 21.79 kilonewton. Then alpha R, that is tan inverse sigma of Y by sigma of X, and that angle is coming 36.58 degree. So this is how we can calculate resultant of two concurrent forces by means of resolution. Now solving same problem by means of parallelogram law, and of course with by analytical method, that is by formula. R is given here root of P square plus Q square plus 2PQ cos theta, and if you put values of P 10 square, Q that is 15 square plus 2 into P that is 10, Q that is 15, and cos theta that is 60 degree here. So finally we will get value 21.79 kN. Direction, that is alpha of resultant with P tan inverse Q, formula is Q sin theta divided by P plus Q cos theta. Putting values we will get angle 36.58 degree. Now you can compare the results by resolution method and parallelogram method. Here resultant was 21.79, while here is also 21.79. Alpha R 36.58, and here alpha R is also 36.58. So values calculated by resolution method or parallelogram law method will give exactly the same values, but mostly when two concurrent forces case is given and you are asked to find out resultant force, then it is convenient to use parallelogram law compared to resolution method. Otherwise we can use any method. So this is how this problem can be solved. Now one more problem solved using parallelogram law. Say here two forces 10 kN and 15 kN, angle between them is 30 degree. So here to find out resultant, again using R is equal to root of P square plus Q square plus 2PQ cos theta, putting values of P, Q and theta in the formula, we'll get R is equal to 24.18 kilonewton, and angle of resultant alpha R with P tan inverse Q sin theta divided by P plus Q cos theta. Putting values of P, Q and theta, we'll get alpha R 18.07 degree, and that is with force, with respect to force P. Then suppose in this problem here what is different, here force P is compressive nature because it is acting towards point, so it is of compressive nature, and here this force Q is of tensile nature. So here nature of these two forces is different. Here it is compressive nature, nature of this force is Q, though they are concurrent, and it's a case of two concurrent forces. To find resultant using law parallelogram, putting this equation. Now P here, actually we derived formula in which two concurrent forces were tensile nature. while here it is one is compressive and other is tensile. So what is to be done here? Whatever compressive force you will have to show as minus here, okay, and tensile force as plus. So P would be here minus, so minus 100 square plus Q is tensile, so plus 60 square plus 2, P is minus because compressive, Q 60, and cos angle between these two. Angle between these two is 80 degree here. So finding this value, we'll get R is equal to 107.31 kilonewton. And then angle of that resultant force is given by this formula, tan inverse Q sin theta divided by P plus Q cos theta, and we'll get on putting values alpha R minus 33.41 with P. But say we can solve this problem in other way also. Here you have already learnt law of transmissibility of force. So as per that law, we can show a force anywhere on its line. So here say line of P will be this, okay. So instead of showing P here, we can show that force P anywhere on its line, means we can show that force P from this point onwards on this line and the same line, and it can be shown like this, okay. So instead of showing P here like this, we have shown P on its line passing through this point, okay. So in doing so, we are not changing the effect of these forces on this particle or on this point. So but now angle between this line, this force, and this Q will be changed, because here it was 80 measured between these two. Now here this angle will be this. So there will be change in angle, change in value of theta here, and by geometry you can see this angle is 180 minus this angle. So we can write this angle as 180 minus 80, that will give you 100. So now we have converted this force system, which was one force compressive and another force tensile. We have converted both of them as tensile, or we have kept the two forces as tensile. Now using same formula, but here in case of minus P in the previous case, here it is considered now as plus. So 100 square plus 60 square plus 2, P means 100, Q that is 60, and angle is now 100 degree. So here in the previous case we have taken P as minus and angle as it was given between them, while here we have converted that force into the tensile force, and angle, changed angle we are writing as 100. So calculating this value, we will get 107.31, which was in the previous case also same value. So in doing so, there will not be any change in the value of resultant force. Same way angle also, alpha R can be calculated, and that alpha R will come same as calculated in the first case, okay. So this is how this type of problem can be solved. We can solve by this means or by second means, that is this means. Their answer will be the same. Now suppose on parallelogram law you are asked to solve problem like this. Here say it is given, prove resultant of two equal concurrent forces, that is R is equal to 2P cos theta by 2. So to prove this, what to do? We'll it is a case of two equal concurrent forces. So first of all we'll write the formula given by parallelogram law, that is R is equal to root of P square plus Q square plus 2PQ cos theta, and here two forces are equal, so P will keep as P Q, in place of Q we will put value as P, because Q and P are equal. 2P, in place of Q we are writing Q cos theta. Okay, finally simplifying, this value will be 2r square is equal to 2p square into bracket 1 plus cos theta. Simplifying, we'll get, because 2 cos square theta by 2, we can write that value as cos square theta by 2. Here it is given in the geometry that 1 plus cos theta is equal to 2 cos square theta by 2. So using this formula, or this mathematical formula, we can place in case of 2 cos square theta by 2, in place of 1 plus cos theta, 2 cos square theta by 2. So finally simplifying, we will get 4p square cos square theta by 2. So here it is r square is equal to 4p square cos square theta by 2. So making square root of it, r is given by 2p cos theta by 2. So this is how this formula, or r is equal to 2p cos theta by 2 is derived. The next problem, here asked to find the angle between two equal concurrent forces F when their resultant is also equal to F. So here what is given? Two forces, and they are having the same magnitude F and F, and their resultant is also coming F. Now using parallelogram law, R is given by this formula. So putting values of each force, instead of P here it is F, instead of Q it is also F. So 2F into F cos theta. So but the resultant is also coming F, so putting in place of R also F here, so we will get F square is equal to 2F square plus 2F square cos theta, and simplifying we will get 1 minus cos theta is equal to 1/2, or we can say theta is equal to 120 degree. So this is how we can find angle theta here, which is angle between two concurrent forces, angle between two concurrent forces. One more problem, two forces whose magnitudes are in ratio of 3:5 give a resultant of 35 Newton. If the angle of inclination between the forces is 60 degree, find the magnitude of forces. So here in this case, two forces P and Q are given, but they are not given the values, but ratio of their values is given, which is 3:5. So here we can write P by Q is equal to 3/5. So if we write in terms of P, then P is equal to 3/5 Q. Now using parallelogram law, and already R is given 35 Newton, so in place of R we can write as 35. So here in the formula, 35 square is equal to square of 35 is 1225, which is equal to, as in this formula, P square, that is P is 3/5 Q, square of that, plus Q square, we are keeping Q as it is, plus 2 P means 3/5 Q, Q as it is, cos, angle between P and Q is given, cos theta is 60 here. So on simplifying, this is in terms of Q only, so we can find Q square is equal to 625. So Q is equal to 25 Newton. And knowing Q and using interrelation given, we can find P as 3/5 Q equal to 15 Newton here. So this is how this problem can be solved. Now next problem, here you are asked to find Q and alpha R with P. Figure is already given, in which P is 80 kilonewton and Q is unknown, but resultant is resultant of this P and Q is given as 200 kilonewton, and also angle between P and Q is given 90 degree. So you are asked to find unknown force Q and angle of resultant force with P. So once again, using parallelogram law for these two concurrent forces, R is equal to root of P square plus Q square plus 2PQ cos theta, but R here is 200 kilonewton given, so in place of R we can write 200 is equal to root of P is given already 80 square plus Q not given, so Q square plus 2 P, that is 80 Q cos, angle between these two forces is given 90 degree, so cos 90. So cos 90 here, this term will be equal to 0 because cos 90 is equal to 0. So what remains? Root of from this we will get Q square is equal to 33,600. So square root of that value will give you the Q value, which is 183.3 kilonewton. Then now we are having Q available because previously it was unknown. Now we can use formula of direction of resultant force with P, and we can find that angle. So tan inverse Q sin theta divided by P plus Q cos theta. Putting value of P and Q, we can find angle of resultant force with respect to P, and which is coming 66.42 degree. Now in this problem, say you are asked to find out the magnitude of two forces such that if they act at 90 degree, their resultant is root 40 kilonewton. But if they act at 60 degree, then their resultant is root 52 kilonewton. So if this type of situation is given, then how to find two forces P and Q? We can use parallelogram law. So actually two cases given. One case P and Q unknown, here also P and Q unknown, but here angle between them is 90 degree and their resultant is given root 40. So putting these values here, R is equal to root 40 P square plus Q square 2 PQ cos 90, and this part will become 0 because cos 90 is 0. So we will have value P square plus Q square is equal to 40 kilonewton, right? This is one. And from second case, for the same two forces P and Q, we can use this formula and put the values. Finally we will get P square plus Q square plus 2PQ is equal to 52, but P square plus Q square already from this case we are getting 40, so we can put that value here in place of P square plus Q square. So we will get value of PQ here. So PQ from the second case we are getting 12. So then by using this clue, that is say square of P plus Q, then it is given by P square plus Q square plus 2 PQ. This is nothing but expansion of P plus Q square, and plus sign, then we will get plus sign here, minus sign, that is P minus Q raised to 2, then we will get P square plus Q square minus 2 PQ. So here writing values in place of P square plus Q square we can write 40, and in place of PQ we can take this value 12, and we'll then get P plus Q as 64, and P minus Q if taken, then it will be 16. So solving these two equations, we will get P is equal to 6 kilonewton and Q is equal to 2 kilonewton. So I think now you are very much conversant with parallelogram law, and you are also aware when this law is used and how it is used, how to find resultant force in magnitude and direction of resultant force using parallelogram law. So I think you are now in a position to handle or to solve any problem related to parallelogram law. I say thank you now.